Welcome to Kirchoff Practice problem number 2. Alrighty, so this is slightly different than the last one we did. It's just a little bit different configuration so you can see how it works in another setting. So, first things first, step 1, draw your currents. So, I have the current through my battery. I'm going to assume it's going this way. I'm going to call you I1. But that's going to be the same current that goes all the way up to this junction. And it's going to be the same current that comes all the way back here, all the way up here, and all the way over here. Boop, 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 boop. So everything along the same wire has the same current. So purple is I1. Just going to throw a couple labels in there so it doesn't get lost. Alright, so when we get to this junction here, my I1 splits, so I get some current going this way. I'm going to call you I2. And I also get some current going through this branch. I'm going to call you I3. Now again, the direction that you draw these does not actually matter. I very well could have said that I3 goes this way too. Or I could have said I1 goes this way. If the direction you drew it is not the actual direction, that will reveal itself when you calculate your currents, because you'll get a big fat minus sign in front. Alright, so let's look at our junctions. Junctions. So I have a junction here, and I have a junction here. So here, my current coming in is I1. My current coming out is I2 plus I3. Here, my current going in is I2 and I3, and coming out of this junction is I1. So again, when you only have 2 junctions, your junctions are pretty much always going to be identical, which is, you know, kind of silly, but yeah, I don't even know how words, all right, forget it. We had 1 equation, even though we wrote down 2. There we go, that's what I was trying to say. I can't talk today. All right, so now we're gonna do our loops. So I'm a big fan of clockwise, so my first loop, I'm going to start here, just because I want to start there. So my first loop is going to come this way, whoop, 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 over to this junction, and then it's going to go down this way and back to where we started. Okay, so my first loop is going to go here all the way around, take the bottom branch, and get here. My second loop, it's going to start here, go all the way around. Can you even see that with this yellow? Yeah, you can kind of see it. Alright, sweet. Gonna go all the way around, whoop, and instead of taking the bottom branch, it's gonna take the top branch. And then my third loop, I'm gonna start at the same spot, and I'm gonna go this way. Alright. It's loop number 1. My orange loop. So I start here, I go boop a doop a doop boop 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 a doop a boop 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 boop, hit this resistor. I drew my current going this way, which is the direction I'm traveling. So remember our convention, if we're going through the resistor the same way the current is drawn, that's a minus. V equals IR, so it's an I1 times 4 ohms. Hit this resistor. I'm going with the current again, so it's going to be minus I1 times 5 ohms. I hit a battery. I'm going from minus to plus, so I'm being boosted by 6 volts. So that's plus 6 volts. Hit this resistor with the current still, so minus I1 times 6 ohms. Hit a battery, going from minus to plus, so I'm being boosted by 2 volts. Resistor with the current, so minus I1 times 1 ohm. So now my orange loop takes this bottom branch, so I'm going to go this way. Hit a resistor. That's going with the current I drew, so that's with I3. So minus I3 times 2 ohms. Back where I started, so that's all equal to 0. Alright, so we're going to clean this up a little bit because it's kind of long and gross the way it's written now. So I have some I1s. I have minus 4, minus 5, so that's minus 9. Minus 6 is minus 15. Minus 1 is minus 16. Minus 16. So I have 6 volts plus 2 volts is 8 volts. And then I have my 1 minus I3 times 2 ohms is equal to 0. So that's a lot shorter and nicer. All right. Let's look at loop number 2. Hopefully you can see the yellow. All right, so loop number 2. I'm gonna start here again. Hit this resistor with the current. So the first entire half of this chunk is gonna be the same as our orange one. So I hit that resistor going with the current. Hit this resistor going with the current. So it's minus I1, 5 ohms. Hit this battery, get boosted, plus 6 volts. This resistor is going with the current, so minus I1, 6 ohms. Battery is boosting me, plus 2 volts. Losing I1 times 1 ohm. But now I'm going through this top branch because I'm following the yellow path now. So now I'm going from plus to minus, so I'm dropping 4 volts. Now I'm going with the current I2, so that's minus I2 times 3 ohms, and I'm back where I started. So we're going to clean this guy up a little bit again. So we got our I1, we have minus 4, minus 5, so that's minus 9. Minus 6 is minus 15. Minus 1 is minus 16. I have my 6 volts plus 2 volts. So it's 8 volts minus 4 volts. So 8 minus 4 is plus 4. So did you. Check, check, check. And now minus I2 times 3 ohms is equal to 0. So nice and short. Shorter version. So I was just collecting like terms. So now I'm going to follow my green loop. So I start here. I'm going around this way because that's how I drew my green loop. I hit this resistor, but now I'm going against the current that I drew. So the current through this resistor is I3. I drew it this way, but I'm traveling this way along my green loop. So that's going to be plus I3 times 2 ohms. So now I keep traveling along, boop, 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 boop. I hit this battery. I'm going from plus to minus, so I'm losing 4 volts. Now I'm going through this resistor, which is with the current. So it's minus I2 times 3 ohms. And now I'm back to where I started. So that's equal to 0. Okay, so now I have a whole bunch of equations. I have this equation from my orange loop. I have this equation from my yellow loop. I have this equation from my green loop. And then I have my junction. So I have 4 equations, and here I have 4 unknowns. I have 3 unknowns. Wow, I can't talk today. I have I1, I2, and I3. That's what I'm missing. So we have plenty of information to solve for this. So let's start off. I1 is equal to I2 plus I3. So let's take that and shove it in to equation number 1. Okay, so equation number 1 is going to become I1, which is I2 plus I3, times minus 16 ohms plus 8 volts minus I3 times 2 ohms. And that's equal to 0. So now I'm going to solve for either I2 or I3, whatever you choose. So I'm going to break this out. So I have minus I2 times 16 ohms minus I3 times 16 ohms plus 8 volts minus I3 times 2 ohms is equal to 0. I'm going to combine my I3s. So I have minus 16 I3 minus 2 I3. So that's minus 18 ohms I3. I have my plus 8 volts, and I have my minus I2 times 16 ohms equal to 0. Okay, so I'm going to move I2 over. So I have minus I3 times 18 ohms plus 8 volts is equal to I2. And then I'm going to divide by 16 ohms. Okay, so this is our next stage, an expression for I2 in terms of I3. So now let's look at our next one. So I can either do my yellow box or my green box, but I2 is written in terms of I3. So I want to choose the equation that has I2s and I3s in it so I can solve for one. So my green box has I2s and I3s, so I'm going to stuff it into my green box. So for my green box, I have I have I3 times 2 ohms minus 4 volts minus I2, which was minus I3 times 18 ohms plus 8 volts over 16 ohms. So that was I2, and then that's all times 3 ohms is equal to 0. So now I'm going to simplify this. Okay, so I've got I3 with 2 ohms. I've got a 4 volts. I have a plus, so minus times a minus, I3, 18 times 3 divided by 16. 18 times 3 divided by 16 is going to be 3.375 ohms. Then I have minus 8 volts times 3 ohms over 16. So that's minus 8 times 3 over 16. So that's 1.5 volts is equal to 0. So now I can combine my volts. So minus 4 minus 1.5 is minus 5.5 volts. Then this many ohms plus that many ohms, so 3.375 plus 2 is 5.375 times I3. So if I move that to the other side, I3 is 5.5 volts over 5.375 ohms. So I3 is equal to 1.023 amps. So I got a positive number, which means the direction I drew I3 up here, my blue line, is the direction it's actually traveling. Sweet. Okay, so now I have a number for I3, so I can come back and stuff that up here. So I have minus I3, which is 1.023 amps, times 18 ohms plus 8 volts all over 16 ohms was I2. So I2 is that times 18 plus 8 all divided by 16. So I2 was a minus 0.65 amps. So I got a minus sign here. So that means I2 is actually flowing the opposite direction of how I drew it. So I2 is flowing this way in reality. Okay? So now I can go back to my junction rule. I1 is I2 plus I3. So I1 is I2 plus I3. So that's going to be my negative 0.65 plus my 1.023. So that's going to be 0.37 amps. The end.